two variable analysis day one. A statistician does two variable analysis when they have two different variables and they want to know if or how they are associated. For example, we often think we have a independent variable, something that as it changes, it might affect the dependent variable. So in this case, height, okay, the taller you get, usually the more you weigh. Now that's not always true. You might be super tall, but just be really, really skinny. Or you might be fairly short, but you love your donuts, or you have a thyroid issue, and you are really, really tall. But for the most part, there seems to be this type of linear relationship, and that's the type of relationship we're going to look at. So let's look down here. Okay, and what we have is the height and weight of a squad of hockey players. And what they've done is they've given every hockey player instead of a name, they've just given them a letter. Okay, that's categorical, not a big deal. And we're going to ask some questions and think about it. Are these variables categorical or quantitative? Well, besides the names, the height and the weight are quantitative because we're measuring. Okay, what is the dependent variable? Well, your weight tends to depend on your height, right? There's more of you, you're taller, so you weigh more. What would the scatter plot look like? And are the points close to being linear? Well, if you look, looks like that, and yeah, it could be a line that goes through there. So see below. Does an increase in the independent variable generally cause an increase or decrease in the dependent variable? Well, let's see, as this one goes up, this one tends to go up. So it's generally causing an increase. Okay, and then these are the two questions we're going to answer. Is there a way of indicating the strength of the connection? And how can we find the equation of the line of best fit? Okay, and then of course, how could we use it? So we're going to start with section 20A from our book and talk about correlation. Correlation means that there's a linear association between two variables. Never use the word correlation unless you're talking about something with a line. And then there are some steps to correlation. Okay, the first step is to look and see the direction. And really it's more about the slope. Okay, this is heading up, so it's positive. This is heading down, so it's negative. And this seems to have none, no slope or no association. Okay. Step number 2. All right, I actually paused it. Before I go into step number 2, let's look at step number 1. It has direction or any type of pattern is what we're looking for. So here we have a positive pattern and a negative pattern and really no pattern at all. Okay. All right, step number 2 is to look at the spread to make a judgment about the strength. How well do the points fit the line? Well, here they're pretty close to the line, right? So it's strong, here I would say moderate, and this one is pretty weak. There's still an upward trend, but it's weak. And so you always say positive strong, positive moderate, positive weak. And similarly here, this would be negative strong, negative moderate, or negative weak. All right, the third thing we want to look for is it even linear? Okay, yeah, this one is. This one, no. This is more logarithmic. Sometimes they'll come in a parabola. Sometimes they'll be exponential. Okay, so you have to look to see, is it even linear? There are other things we can do if it's not. And lastly, the fourth step is to look for outliers. Okay, this one that's all the way far from the data point, you might think is an outlier, but it's not. And that is because it's still right in line with our line of best fit. Okay, however, this one here is an outlier. This might be the person that is, you know, when we were talking about before, it would be the really tall person who's kind of skinny. In this case, this is high whenever this goes up, something else is going down, but this one is also high. So I don't know what the story problem is for that. Okay, so an outlier. And with outliers, sometimes they can be an error, and sometimes they can be the most important point. Okay, so you have to really pay attention to the outlier. Make sure you look at it and decide what to do. And we'll discuss that in class. Okay, so we have some more vocab words. Causation. That's the correlation between variables. Does not necessarily mean that one causes the other. Okay, for example, ice cream sales go up in the summer, and so do shark attacks. So you might have something look like this. The more ice cream that's purchased, the more people are eaten by sharks. But obviously, though there's a correlation there, ice cream does not cause shark attacks. It's just that summertime is when people buy more ice cream. Okay? Summertime is when people swim more and when the sharks come out. So there's that relationship there, but it's not a causation. Okay, a causal relationship is when variables are related so that when one changes, the other changes. Okay. All right, so let's talk about the line of best fit. We're skipping 20b, and we'll go back to that, and we're going to talk about 20c and regression. Regression is the method of fitting a line to a set of data, and there are two ways to do it. One by eye, and one LSRL, least square regression line. And this is the perfect way. And we can do it with a formula. And there's several of them. We'll use the formula today. Or later after today, graphing, display, calculator, because nobody would want to do it by hand if there were lots of points. But for right now, we're going to talk about doing it by eye. Okay, and here's the deal. The least square regression line, before I even start, the least square regression line always goes through the point x bar, y bar, which would be the average of all of the data points for height and the average of all of the data points for weight. This would be x bar and y bar. So if you were going to do it by eye, you probably would figure out x bar, y bar, and make sure your line of best fit goes through that. But that's just to make sure you have a really good by eye line of best fit. If worse comes to worse, just pick 2 points. So I went ahead and picked 2 hockey players. Okay, this player had a height of 160, and remember this is centimeters or meters, I have to look it up, and 64 kilograms. Okay, so this is an X value, this is an X value, this is a Y value, and a Y value, and we want to find the line of best fit. So let's first look at those points, the 160 and 64, 160 and 64, that's right here. And then the other one, 190 and 88, that's not even a player. So this is an actual hockey player point. This is not. And so what I did was I just, by eye, I drew in this line and said, I think this is the line that fits the best. And then I picked a point on it that was 190 and 88. If I were going to do this example again, I would instead use this one player maybe and my X bar, Y bar to have a better approximation. But for today, we have these 2 points. This line appears to go through the data fairly well. And so now we're going to do Algebra 1. How do you find the equation of a line? Well, first off, you need the slope. So the slope is y minus y over x minus x. So I'm going to go y2 minus y1, but you don't have to do that way. That's 88 minus 64 all over 190 minus 160, which is going to give me 24 over 30. Again, that's these 2 points. Make sure they line up, y over x, and then these 2 points, y over x, so y minus y over x minus x, which, if I simplified that, simplifies down to 4/5. So now I have the slope of my equation. Once you have a slope, you need a point. Okay, so we have 2 ways of doing this. We have the slope point formula. And we also have the, slope point we're going to do over here. We also have the slope and y-intercept. So this one is y equals mx plus b, right? Slope and y-intercept. And so we're going to go ahead and just plug in our points. Well, we know we have an x and a y at 160 and 64. So our y is 64. So we're going to say 64 equals, our slope was 4/5. And with that y, our x was 160 plus b. Okay, if you solve this, you get 64 equals 4/5 times 160 is 128 plus b minus 128 from both sides, which gives you negative 64 equals b. So my equation is y equals 4/5 x minus 64. And I'm going to call that a y hat because it's a prediction equation. All right, we'll talk about that in class. The other formula that you may have seen is y minus y1 equals m times x minus x1, where this is where you plug in the slope and 1 point again. Okay. So we have y minus equals something x minus. So again, I'm just going to go ahead and plug in. My slope was 4/5. One of my x's happened to be 160. My other x was, or my y was 64. Okay. And so what we get is y minus 64. Now we're going to distribute this equals 4/5 x plus 1/4 times negative 160 is going to be negative 128. Add 64 to both sides, and you get y equals 4/5 x minus 64. So they're both going to give you the same equation. Okay. That is our line of best fit. That's the one that we drew in, but we really want the perfect one, and we'll talk about that next time.